Some of you may have heard a CBC documentary, CBC radio documentary this fall on problems with high-rise buildings in Toronto. We thought that was a very interesting topic that really deserved more discussion, and we decided to make that a panel at this conference this year. And we brought in 3 distinguished members of the building community to the construction community to deal with this subject in a little more detail. The 3 panelists that are going to present today, starting from my right and moving to the outside, are Mark Brook. Mark is a principal of BVDA Facade Engineering. He has been involved in high-rise building design and construction, specifically from the perspective of the building envelope, for over 30 years. Mark was involved with the recladding of First Canadian Place and was the principal investigating engineer for the glass breakage incidents plaguing Toronto last summer. He was on the expert advisory panel that provided recommendations for dealing with that problem to the Ministry of Municipal Affairs and Housing. To his right is Tim Gorley. Tim is an executive vice president of Page & Steele, IBI Group Architects, as well as director of the IBI Group, and is currently in charge of both the production and contract administration departments. He is also a project architect for many of the firm's largest projects. These projects include several residential towers of 40 to 50 stories. He is currently involved in the preliminary design of towers exceeding 60 stories. Tim also served on the expert advisory panel on glass panels in balcony guards. And to Tim's right is John Straube. Professor Straube teaches courses in building science, structural design, and material science in the Department of Civil Engineering and the School of Architecture at the University of Waterloo. He is a researcher and consultant in the areas of building enclosure design, moisture physics, and whole building performance as a consultant. John has applied field measurements, laboratory testing, and computer simulations to a wide range of commercial and residential buildings across Canada and the US, and as far away as Mongolia and New Zealand. And John's going to be our first presenter.
First of all, thanks for the invitation. This is the first time I've been to this conference. Lots of interesting topics this morning already. I'd like to point out that the University of Waterloo sponsored the breakfast, which I only noticed by accident. Certainly as part of a large organization, I don't get to know all these things. The actual series that CBC started on throwaway buildings with Mary Wiens was created because of the falling glass problems that everyone knows about. And that I was asked about the falling glass, but really this is my take on this was that was just a relatively specific thing, and there's a much bigger policy level issue here about high-rise buildings. And my concern was that I was focused on high-rise residential, and I think Mark's going to talk a bit about different technology used between curtain walls and window walls. And there's a whole bunch of different levels of quality and hence durability and performance. Although the big issue is that the performance is the problem. Whether you're using a high-performance curtain wall, you still have problems with energy performance, or whether you're using a low-performance residential-style system. As we heard from the last presenter, growth in the GTA has continued to go on, and we're going to need more density. And this leads some people to believe that we need high-rise, and clearly we're going to need higher density. That's not much in question. And so this issue is not going to go away. And certainly any drive down the Gardiner would suggest to us that we're going to build a lot of more high-rise residential. What's interesting about driving down the Gardiner is that there's only one architectural solution to high-rise residential, and that is, it seems, that all of them look exactly the same because they use exactly the same solution, which is an aluminum and glass curtain wall system. Now, one of the indicators that there may be something we have to watch here is our history. The last time we had a big multi-unit residential building boom occurred in the late 60s. And in fact, if you think that we're building a lot of condos now, I wonder what it must have been like in the late 60s, where the number of multi-unit residential buildings being built was greater on a per-year basis than it is now, which is, to me, a shocking statistic. This is a plot here of CMHC's registrations for multi-unit residential buildings between 1950 and 2006 or 2007, and you can see the number of units that peaked per year at the end of the 1960s. Now, as a result of this, we now have these towers that were built that are now 40 years old, and there's also lots of articles you can read in the Toronto Star and the Globe and Mail about, oh boy, what do we do with all of these buildings that we built out of concrete, brick, and masonry that are now becoming urban ghettos because we can't actually afford to repair them very well. Now, I point out that these buildings actually, in most cases, have better thermal performance than the new condominium buildings that we're building. They're also made of things like brick and mortar, which has a little bit longer of a track record of durability than caulking. And so these are the things at a very simple level that makes me ask questions, and that's what precipitated this. But like any of these problems, it's a little bit more complex than just saying, oh, well, we're using systems that rely on caulking and we're using very low R value. But I think that's the reason for the discussion. This is a current sort of the only design paradigm that people seem to be aware of how to build, although there are alternatives out there that other people in other cities have figured out. So I want to raise a couple of issues on a technical level, one being heat loss. An R value for a code, 2010 code value, curtain wall or window wall, if you include the aluminum frames, is around R2.5, whereas the walls, the opaque walls, is around 15. And that means that the glazed part of the building loses 6 times more heat than the non-glazed part. Now, the good news is we have compact buildings, so they have less area than, say, a single-family home, but not 6 times less. And the issues here are not the heat flow through the glass, that's one issue, but it's the heat flow through the frames and the way the frames are connected to the structure, and all of those things that are made of dense materials are highly conductive to heat flow. So the glazing overall system is what I'm going to talk about, and a lot of people, including code officials, design engineers, and architects, seem to be willingly ignoring the reality. I can get an R4 double-glazed low-E argon window unit, but when I put it into a typical, this is a high-performance green building, when I add the frame effects, I'm down to R2.5. I can take R12 of Rockwool insulation in the spandrel panel, but when I include the metal back pan and the aluminum frames, I'm down to R4, and so in this particular wall, which continued from the parapet to the sidewalk level, I'm at R3.5. You can go to Mountain Equipment Co-op and buy a jacket for $100 that has twice this R value. So the problem isn't just the aluminum frames and the windows, it's also now we add balconies, which have an R value, if you're lucky, of about 1. And so this is what we're building row upon Mies van der Rohe of, are systems that have very low R values. So that affects comfort and energy use. But another side of things is that heat gain through a modern window. Decent windows tend to be 15 to 25 times that from a modern wall. And so when you have a warm, sunny day in the middle of August, Ontario has a problem generating enough electricity. And part of that is because of the massive growth in air conditioning. And it shouldn't be a surprise walking around downtown Toronto looking at all of the greenhouses that we've constructed that solar gain is going to dominate the air conditioning peak loads. And so what we can do is improve performance by using better and better glass. That costs money, so we don't use it in condos. But in, say, a bank building, we can cut this number from being 20 times worse to as little as 10 times worse, which is still 10 times worse. The long-term sleeper issue that we can't predict, and I can't prove technically, is the issue of low-cost designs that rely on organic sealants, whether they be EPDM, or they use PVC, or they use polyurethane or silicone sealants. These things break down with time. As the glass and the aluminum move, expand and contract from -20 nights to +30-degree days, and as all of those organic materials, other than silicone, are exposed to UV radiation, they naturally break down. This happens in all buildings, and all buildings require maintenance to do that. But the distinction here is that when we build buildings that are entirely made of glass and aluminum, or almost entirely, there are a lot more of these gaskets that require a lot more maintenance. And then when we look at the difference between buying a high-rise condominium versus a low-rise townhouse, the access costs are huge. So the cost to get your window changed in a 3-story townhouse downtown is half the cost of trying to change that same window in a high-rise building because of the access challenges. And eventually, we're going to have a mayor's renewal project for these towers. You know, I'm sure it'll be 2035 or something like that, and we'll put some public money into saying, how do we fix these buildings? And we'll have to figure out, can we overclad them? Can we remove it? And at the very least, I think it would be good if we would actually have a plan for how we can remove and replace and repair and upgrade all of these skins in the 20-year to 35-year timeline when it looks like it's going to be necessary. It's actually technically relatively straightforward to fix the towers of the 70s, the skin of them. It's going to be much more challenging to fix the new generation of buildings. And I'm sure, Mark, I've also worked on the First Canadian Place skin repair. And, you know, these things are not cheap. These things are not cheap. So what durability is desirable, somebody asked. Well, it's unclear. No, we could make a decision that at least it should last the life of the mortgage. I think that'd be a pretty good thing. But that said, many of the towers are not meeting that goal if you consider major repairs or maintenance costs. And we have experience in other jurisdictions of buildings that are 10 to 20 years old requiring 5 or 10% of building cost in repair and renewal. And the question is, when do we start doing 30% cost of building renewals? Is that 30 years out? These are the kind of engineering decisions that should be planned out. And it doesn't appear that people are making those decisions very carefully. How do we avoid this other 1,000 towers that we have right now in Toronto? We're building the next 1,000, and that looks to me like they're a lot worse and a lot less durable. And the big mistake, I think, is that we're always assuming that high rise is equal to high density. And again, much like the transit scenario that we talked about last session, you could travel around the world and look at alternative solutions. You could look at cities, you know, crappy cities to live in like Vienna, Stockholm, Paris, Berlin, where you could see that, oh wow, they have higher density than Toronto. They can afford more transit, and they don't have a whole bunch of 30 to 50-story towers. So I'm not against 30 to 50-story towers, but I am against the closing down of engineering solutions, architectural solutions, urban planning solutions, and societal solutions that assume that the only way that works is the way that's the best for that developer on that job, on that particular project site. And that's back to what is public policy? How can Paris look like this? And tourists from around the world, more than even come to Toronto, come to Paris. And people make very few romantic movies in Toronto. But they could, and that should be one of our goals. At the end of the day, there are lots of other solutions. I'm showing you various solutions here of high-density housing, solutions that don't necessarily have to use only window walls that apparently are the solution that du jour here, that could be used that may be able to avoid some of these problems, or we could improve the performance and the design of the systems that we are building to actually get to real energy targets that are, I would say, our target right now half of what we're currently building. That's completely possible economically at the same cost of construction, and there's lots of examples out there. But there's right now no incentive to, if you're building a building and selling it to an uninformed consumer, there's no real drive to actually build those buildings. And so I think we need a lemon law to protect consumers from their biggest personal investment of their life from buying something that may have high energy costs and durability problems. So that's where the public policy, I think, comes into this. So I think I'm ready to switch it over to Tim.
I'm going to try to give some context to the issue. I firmly believe that high-rise buildings are not throwaway, and in the Toronto context and other parts of the world, they are definitely here to stay. One quick comment about context and the type of buildings for the type of city. As you all know, Toronto is particularly known for its single-family housing and its tree canopy. The interesting thing is, how do you create 100,000 more spaces per annum in a city where you have an extraordinarily strong opposition to growth? Recently, for example, you probably have read that there are much stronger opposition to the 4- and 5-story condos, 20-unit condo proposals for 4 or 5 locations on Queen Street in the Beaches as compared to a 60-story condo in downtown Toronto. That's just where the situation is politically, and I think that's part of the context that we have to talk about. In any case, Page & Steele is a very old company, as you probably know, the oldest, I believe, the oldest continuing architectural practice in Toronto, and our residential work goes back a long way. Let's go forward. Okay. You'll see here the Garden Court project, which was probably done 70-plus years ago. Still standing, still extremely successful rental project. Admittedly, it's a fairly small building, a low-rise building. It's complex. It has balconies. It's been well maintained. It's rental, not condominium, obviously. Very quickly in that same period, Page & Steele did much larger residential buildings. This one happens to be directly across the street from our office, so I see it every day. There are 2 of them on St. Clair. Very successful rental buildings. They've been maintained by the owners and who have recognized their profitability. And they haven't shown any serious problems of decline, but they have been maintained as we all maintain our own houses. The Benvenuto, another major building built a little bit later in the early 50s, I believe, is an extremely popular location, huge demand for people to live there, and has residents that have been there for 30 and 40 years. A lot more glass in it, bigger units. Over the years, we've, as a company, have done a great number of luxury buildings. This happens to be the Cheddington on Bayview, a building with very large suites and a considerable amount of brick and precast, but still significant amounts of window. I don't particularly myself see the difference between a tall building with a lot of glass wall system as compared to a tall building or a relatively tall building with other products. There are serious complications in the interface between these various materials for all these various materials on a building like Cheddington. Another high-end luxury building in the Post Road area, which was done primarily with precast and perhaps something like 45% vision glass for the whole building. Maintenance is always an issue with these things, but these are condominiums, and to my knowledge, they have had good reserve funds, and the management is actually taking care of them. Another luxury building in the West End on Bloor Street in Etobicoke, again using multiple materials in a traditional fashion. The interesting thing is, and it's a cultural thing, is that you tend to find that the more luxurious, more expensive buildings tend to be the desirability of more traditional look is important to these people. And because of that, they're actually ending up with buildings with less glass and more traditional style elements. Apologize for this not being a photograph, but this is 7 King Street, which is King and Yonge Street. We renovated, or we actually retrofitted an old office building something like 17 or 18 years ago. And it's an example of how you can take a building which has real problems. That building, if you recall, if you're old enough to recall it, was for 5 or 6 years surrounded by hoarding because the pieces of the precast of the original office building were falling to the street. So in order to retrofit it, we had to totally remove the exterior skin and rebuild it using the structure and the elevatoring system and not much more to provide this condo, which has been well maintained and has operated for, as I say, 16 or 17 years. This is one of the first, I guess, what you might call all glass towers that we're involved with in Toronto. It's the first of the apartment buildings for Concord when they came to Toronto. It's at Blue Jay Way and Front Street. And it was quite, admittedly, it was building on the example of the very successful work that Concord had done in Vancouver. Around the same time, this is at Yonge and 401, we built the Spectrum, which also is largely glass. We talk about all glass buildings. In fact, these buildings range in vision, the actual amount of vision glass to spandrel glass, which is fully insulated up to R20, it varies between, typically varies between 45 and 70% of the suite area of the building anyway. So this building, I believe, was something like 60% vision glass. Empress Walk is a much larger multiple use building with all sorts of functions at the base, including a major theater and 2 towers built on top of that, which are a mix of precast and glass. This is Prince Arthur on Avenue Road. A lot of brick, a lot of stone, still significant amounts of glass. So I would argue that the technical problems of the building envelope are just as bad or worse even on a building like this. There are issues right now with the brickwork on this building, some concerns about the workmanship in the original construction. This is Water Park City for Lanterra, the first large development that took place immediately east of the CNE, and as you know, that whole area has dramatically changed in the past few years. One Bedford is right on Bloor Street, and a large mix of precast and glass. This particular building had some balcony problems last year, which is another issue that we've got to talk about in terms of high-rise or low-rise for that matter, because the issue relates to any balcony that's over 2 stories high and can cause issues if it's made out of glass. A very large project for the same company at Maple Leaf Square. This was done with, actually these 2 buildings were done in conjunction with KPMB here in Architects in Toronto. The tower portions are largely glass enclosures at about, I think, 60% or slightly less vision glass. A higher end project, which is both hotel and condominiums on Hazelton. As you can see, the condominium portion has significantly more glass than the balcony. The condominium is the upper portion. Largely market driven. One of the comments I have to make is that the architect and the engineer is not the one who determines the amount of glass, as much as we might argue about it at times and worry about the methods. The mechanical engineer or the modeling engineer may work out the energy efficiency, but I know that they're typically challenged to come up with the solution to what they want for marketing purposes. This is the L Tower, which we're doing in conjunction with the Liebskin studio from New York. It's an early model rendering, and the lower portion, the lower low-rise portion hasn't been built, but currently that building is at 37, 38 stories, and Mark can probably tell you, I think he was just in China to visit the glassworks that was providing the material for that. It's a combination of window wall and curtain wall because of technical reasons. More recent, slightly upscale building that we've done on Avenue Road at St. Clair, again, using stone and brick to a much larger extent because that's what that market, what we were told that market was looking for. Still over 40% glass. The whole Concord facility, our project at the railway lands, it's called City Place, consists of something like 20 towers. We're currently just starting construction on 2 more. That bridge that you see between the 2 buildings will be lifted into place in June. Hopefully successfully. It's sitting on the ground right now. The project is an interesting one in that it's designed. The design is done by, I believe, 6 different architects over the past several years. Page and Steele, IBI, has done most of the technical side of the work. In effect, architects of record for it, along with the same group of engineers, including Mark, who's had a lot of involvement with the skins on all of these. These 2 towers were actually designed by Page and Steele as well. They're 49 and 42 stories right on St. Clair. And they are about 60%, on the tower portions, about 60% vision glass within the suites. It was already mentioned, but I think you have to realize that a typical suite of maybe 700 square feet has a frontage of 20 feet wide on the exterior. So its actual glass, even if the glass on the exterior is 100% of the surface area, the glass area represents 20 to 25% of the floor area. As compared to your house, where if you're in a single-family house, all of your exterior walls are exterior, even if they are R20. And your glass area is, certainly in more modern houses, is also at 20 to 25%. Older houses are less, of course. But there is a comparison, and there is an efficiency of building together. The big issue becomes, in my mind, becomes the problems. I'm sorry, that's the Ritz, which we did with Keane Pedersen Fox from New York, and it's a hotel with luxury apartments on top in a very modern style. It's all window wall, which tends to have a better performance, but it still is glass, of course. The Four Seasons Hotel, which is certainly topped off and is supposed to open in August, is a hotel with a condo above and another condo tower to the east, which you see on the left of the picture. And it's all curtain wall. Again, there's a tendency, interestingly enough, and I sort of backs up what John said, there's a tendency to use curtain wall in buildings that are owned or will be continued to be owned by an investor because of maintenance issues. As in office buildings, they see curtain wall as being a better longer-term investment. I don't have this similar one for Toronto, but I thought I'd throw it in here from our sister firm in Vancouver, which has a very similar practice to us. Some time ago, they did a study of tall buildings, and although the now is actually 8 years ago, you can see this dramatic change in residential construction, primarily in the period from 1982 to 2004. Vancouver and Toronto are probably the biggest cities of high-rise condo work in North America, although we see it in a number of American cities and actually participate in it. We're now seeing some more work in Montreal and in Halifax right now. We're working on projects, but this dramatic increase. And the cities, although they don't look alike, have very similar transportation problems. These are some of the kind of projects that were done, and they are a few years old now, even by the by our Vancouver office. So you see the same kind of issues, the same amount of glass. We're building in Highrise, just looking forward, this is a Delta Hotel on Bremner, which is a modified curtain wall project, pushed very hard by the developer to put as much glass in it as possible, as against spandrel glass or insulated wall. Another large project that is currently being marketed. You see this building in the papers right now. In fact, we're just starting working drawings on Scott Street. 60 some odd stories. Another one, Index, which is making use of an existing building beside and on top of it with a very high rise, very small suites geared to people that don't want to make those huge commutes and can walk to their work. That's a very, very big demand in the downtown. The car requirements are significantly less, and the developers are having actual trouble selling the units. So I'm sure we'll discuss the issues quite a lot. Thank you.